Okay, in our third installment of our expanded form, whole number, expanded form video series, we're going to look at one final method to write numbers in expanded form. Okay, so as we learned in the first two videos, we do this so we can have a deeper, this is kind of like giving the definitions now of the language here in math. So we need to have, we have to know what our numbers represent, and it's just like understanding what words mean with the written language, okay? But this is our numerical language. So, again, this 4 doesn't mean that I have, 1, 2, 3, 4. It means when I look at the place value, this 4 actually means I have 4 million of something. So, we learned a couple different ways. So I'm going to go back to method 2 right now. And we know that this is 4 times what? Well, if I look at my number, that 4 is in the millions place. Okay? So that could be 4 times 1 million. Okay? But as you probably noticed that when we write numbers in expanded form like this, they really get expanded. But wait, don't we have a method to shorten numbers up when they get really drawn out? Oh, yes, we do. Exponential form. So I can rewrite, this would be 4 times, and how can I represent a million in exponential form? Well, I have to think back. Well, I got a reminder right here, my 10 fingers. Oh yeah, our number system's based on the number 10. Okay, and then where am I at here? 10. From here to here, 10 times 10 times 10 times 10 times 10 times 10. It happens 6 times, right? So, 10 to the 6th power. Or I can, okay, a million that has how many zeros in it? 1, 2, 3, 4, 5, 6. Okay, so I'm just replacing our traditional way of writing a million with the way we just learned in exponential form. So that would be plus. Plus what? Well, that 5. That 5's not really a 5. That's really a 500,000, or 5 times 10,000. Oh, look at all that. I'm already getting long here, right? So that'd be 5 times 10, base 10. Okay. Well, 5. And if I know, okay, there's no zeros, no anything there, it's going to decrease 1, right? If I go from millions to 100,000s, I lose a 0. So 6 zeros, 5 zeros, or I can count them up. 1, 2, 3, 4, 5. Because remember, 10 times 10 times 10 times 10 times 10. Each place value I go over, I'm getting 10 times bigger. And that 7's not really a 7. That's a 70,000. So, what would that be? Oh, yeah. So that would be to the 4th power. Because, what do I know? Oh, look, I'm probably going to be going off the screen here, because this expanded form takes up so much room. Okay? That 3. That 3 is not really a 3. That's a 3,000. So, how can I write 1,000 in exponential form? Well, it'd be 10 to the 3rd power, and I can, hopefully I start getting a visualization. Okay, I can see those 3 zeros. Plus, and we got another 3. That 3 is not the same value of the 3 to the left of it. It's a little bit less. It's in the hundreds place. So how can I write hundreds in exponential form? Well, that'd be 10 to the 2nd power. Then I have that 4. That 4 is not really represents a 4. It actually represents a 40. How can I represent that in exponential form? Well, still base 10. 40 has 1 0 in it, so it would be 10 to the 1st power. And just 1, right? Over 1. Times 10, right there. And then that 5, the only one, that 5 is actually a 5, right? That's 5. That's actually a 5. So 5 times 10 to the 0 power. A lot of patterns going on here, right? We can see 6, 5, 4, 3, 2, 1, 0. Number of zeros here in a million. 6, 5 zeros, 4, 3, 2, 1, and then the ones place We don't have any zeros because we're not multiplying it by 10. It's where we start. Right? We have to start someplace. Okay? Hope this video was informative to everybody out there. I'm going to show you a couple of example problems. Try those at home. We'll come back in class. We'll see where everybody stands. We'll practice some more, and hopefully everybody's on track. So right here's the example problems. Okay? We got, let's see here, 3,248,962. And then for our second example, 32,078. Okay? I look forward to seeing everybody back in class.